For students, this is Mrs. Thompson. We're in our final section of Chapter 9. And today, and in this section, we're going to be talking about comparing functions and different representations. They may give you an equation with a graph, or a table and an equation, or a table and a graph to compare the different functions, linear functions. We could have a couple of quadratic functions that we're looking at. It could be a couple of exponential functions we're looking at. Just depends on the situation, okay? So this first page is just a summary of everything we've learned. Remember that linear, that's a straight line. As you can see what I've got graphed here. Here's the equation. If I was looking to create an equation, I'd use y equals mx plus b, looking for the slope, the change in y over the change in x, and the y-intercept. And if I had a table, I would look for the constant first difference. Remember quadratic, this is the basic formula. It looks like a parabola on the graph, and I'm looking for a constant second difference. Exponential, here's the basic formula. I need the starting amount and the growth or decay ratio there. And then this is what it looks like on a graph, and it's got constant ratios. So all of these things are things that we have to remember when we do this section. What makes this section particularly vexing for students is you've got to analyze. And most students are like, I don't mind if you ask me to add, subtract, multiply, divide, and crank numbers and crunch numbers. I don't mind doing that. Just don't ask me, what does it mean? And that's exactly what I'm going to be asking you in this section. Okay, so our first example, we're going to compare linear functions. So both the representations will be linear. We're going to compare them. We're going to talk about what those representations mean. Deirdre and Beth each deposit money into their checking accounts weekly. Their account information for the past several weeks is shown below. And what they want us to do is they want us to compare their slopes and compare their y-intercepts. Find meaning in them. So this is what I would advise you to do. Let's call Deirdre D, and we'll call Beth B. And we're going to make a little chart here, okay? And I love charting information. It's just a clean way to write everything out. And we'll do slope here, and we'll do y-intercepts here. Okay, and so there's our basic chart. And then we're going to make some statements that kind of wraps up what everything means. Let's verify that this is actually what it says it is, that it's linear. I know that this says it's linear, but I like to verify. I'm not a trusting soul, and make sure they're telling us the right thing. All right, so 60 to 75, I'm going up by 15, 75 to 90, going up 15, 90 to 105, going up 15, and 105 to 120, going up 15. Okay, so definitely we've got a common ratio of positive 15. Clearly it's linear. Beth's graph is a straight line. Clearly that's linear. We're good to go on that. Okay, now to determine their slopes, let's start with Deirdre. Deirdre, remember what I told you, it's the change in y, so it would be that 15, over the change in x. Well, x is going up by 1 each time. Okay, so that's pretty clear. It's 15 over 1, so her slope is 15. Now, number crunching, everyone in my class could figure that out. We got to put meaning to it, okay? Let the table help you with that. Look at the y's. Look right here. What are we measuring? Dollars. That's what 15 means. 15 is a dollar amount. Look at the x. That's weeks. So what do you think $15 per week means? Now hopefully you're going, well, the table indicates that she's putting $15 in every week, and you are interpreting that beautifully, beautifully. Okay, now let's look at Beth. If I'm given a graph of a line, I'm going to try and do rise over run. I would definitely do that for slope. I love doing rise over run for graphs. So they're going by 20s, 20, 40, 60, 80, 100, 120. And then the x's are going by 1s. So I'm going up 20 over 1. Now this has meaning. Your Y, that's your rise, that's dollar amount. So that's $20. And then the run is your weeks, that's your x-axis, that's weeks. So Beth is $20 per week. So Deirdre is putting $15 in a week. Beth's putting $20 a week. So we want to make a statement about that. And you may say something like, Beth is putting more money into her account than Deirdre. And you can use the dollar amounts. You can do whatever you've calculated, or you can be a little more vague in your statement. It is accurate to say that Beth is putting more money into her account than Deirdre each week. That's definitely accurate. You could say Beth is putting $20 per week and Deirdre's only putting $15 per week into their respective accounts, however you wanted to write that. Okay? Now let's go to the y-intercept. When x is 0, y is, and for Deirdre, that would be 60. And for Beth, looking at the graph, we're looking for the point that's on the y-axis. And for her, that would be 40, and that's dollars. Okay, so Deirdre's y-intercept is $60, Beth's y-intercept is $40. What does it mean? Well, this is how much money is in their account. So you could say something like this. Deirdre started with more money in her account. And that would be accurate. And you could, if you wanted to use the numbers, you could say Deirdre had $60 in her account while Beth only had $40 in her account when they started saving money. However you want to word that. Really, there's lots of wordings here that can work. And I don't care, really. I do want to see what the actual numbers are so it's not this random guessing. The numbers drive the answer. So you need the numbers so you can make the interpretation. Okay? So that's it for example 1, comparing linear functions.